दोस्तों जय हिंद जय भारत नमस्कार। In continuation with our discussion standard 12 physics, today I have taken one interesting topic. It is nothing but an electric flux. But before going to the electric flux, let me try to explain what is the flux and how it is being considered. If there is a square pipeline and if the liquid is flowing through that pipeline with a velocity v, how can we declare that how much flux is been there? And later on we will try to understand the flux in terms of electric lines. It's a short topic but quite interesting topic, and later on when we try to understand the dipole arrangement, the electric flux is one of the most important property to understand. But let me try before going to that. I have one pipeline, what I have square pipeline, square box rather than, and from the square box there is a surface ds. You can see this is the surface of the square box. Now from the square box certain type of liquid is flowing and then it is passing through the square box, and the velocity of this particular liquid is v. This I am demonstrating to understand about the flux. There is a square pipeline, square box with a surface ds, and liquid is flowing through the particular square pipeline with a velocity v. Then there is a flow rate. That means at the rate at which the liquid is flowing, which called a flow rate, is nothing but a surface area ds into multiply by the velocity. Moving further, if I replace this particular analogy with a one plane, and then particular plane the electric lines are been passing. In upper circuit we understood the one surface with a ds, liquid is passing through that particular square box with a velocity v. The flow rate is nothing but velocity v into multiply by the surface ds. But if you replace this particular square box by a plane, a simple plane, and then electric lines are passing through the plane, you can see it is cutting the plane and then it is coming out from that particular plane. This particular plane has not same surface area ds and velocity is v. In upper case, in top one, you can see the multiplication of velocity v with a surface area ds, what we called a flow rate, is nothing but a flux of a liquid. But in bottom case you can see, if you analogy with a plane, you can see there are a lot many blue colors electric lines are passing and crossing the plane and coming out. But if I change the plane with a certain angle, now in the right side I have changed the angle, you can see the plane is changed. If you change that particular plane with angle q, that means you can see here the line are passing perfectly through that particular plane. But the outcoming line which is crossing the plane is not perfectly 90 degree, but it is having some angle q. You can see the the lines are cutting the plane with an angle q. What is the difference between these two? Now in upper case we have seen the liquid, but in bottom case we have seen the electric field line are passing through that particular plane, and then the flux is nothing but surface area ds into velocity v. And when we are discussing about the plane, we have to mention the direction n raised to ds. So electric flux is nothing but lines passing with a surface ds with a velocity v is called a electric flux. But if it is having some angle, what we have mentioned in the right side circuit, in that particular case we have to consider the angle also. Now you can see if I change that particular plane, maybe I have taken an angle q, but if I keep it perfectly parallel to the lines, now I will keep, you can see here 180 degree up. You can see that particular right side circuit, if I am keeping that particular if perfectly parallel to the particular lines, that means none of the line is cutting the plane, and this is called electric line are not cutting the plane. When it is a 180 degree, not a single line will cut the surface, so flux will be almost zero. In that particular case, that means message is very clear. When we are discussing about the electric flux, we need to calculate the angle of the plane also. Moving further, that electric flux is nothing but E into surface area ES, and as I said, we have to calculate the angle also. So E electric field into surface area S into cos theta. The cos theta is nothing but angle between electric field lines and the plane, that is called surface area ds. You can see here the angle is angle between E and ES. So electric flux calculation, a simple formula is nothing but electric field lines into surface area multiplied by the cosine of the angle. The total flux passing through the surface, you can see here the electric field lines into surface. The basic definition of electric flux is, if someone asks you what is the basic definition of electric flux, it is nothing but line passing through the plane, the number of electric lines E into passing through the plane surface area delta S multiplied by the cosine of the angle. This is nothing but electric flux. Now you can see here there are two charged particles. One is positive charged particle and second is negative charged particle. Both are differentiated with a distance 2a. This is nothing but a dipole, what we have understood in lesson number 9 and 10. The dipole is an equal and opposite charged particle separated by a distance 2a. Please listen carefully. Once someone asks you what is the dipole, then dipole is nothing but equal and opposite charged particle separated by a distance 2a. And the line connecting the charged particle, you can see here, the line connecting the charged particle defines the direction in a space. You can see the direction of the line, it is coming from negative and going to the positive. By conventions, by default, if no if 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 there is no defined there is no defined line, then by convention of the line always from the negative charge to the positive charge, and this is called a direction of the dipole. You can see here there is a center in between two dipole, a blue color circle is there, you can see here, and this is called a midpoint and this is called a center of the dipole. This is all about the dipole arrangement. Two charged particles separated by a distance 2a. The line always coming from the negative and going to the positive, it is called a direction of the dipole. The midpoint of the dipole is called center of the dipole. The dipole is nothing but equal and opposite charged particles separated by a distance. With this small presentation, we have completed the electric flux and then a small presentation on dipole also. Thank you. Dhanyavad.